Okay, welcome everyone. I'll give people a chance to flow in and we'll see how it's going. Hopefully we can, oh, we already got some visitors. So, cool. So today we're going to be going over BOF files. If you're not familiar with them, they're kind of a cool thing that Cobalt Strike introduced a little while ago that allows you to run C code kind of in a position independent way without creating like shellcode. So it's a way of relocating an image file into memory that can like execute discrete tasks. This is what Cobalt Strike has on their page about it, I think, or for their user guide, which is not a lot. But they introduced him because it's really nice that they already had like PowerShell.NET and like reflective DLL stuff, but that was all getting picked up by AV EDR. And so they came up with this other way that allows you to create like very small and tight C code that is a lot less suspicious to AV and EDRs. And now a ton of projects have started incorporating this file. So like Trusted Sec has like a cough loader that they've built. I meant to pull that up before we started. So they have this cough loader that they've built that's really nice. They had some other stuff, not some other stuff. There's been a few people that have built Python. We're gonna have to test them because last time Anthony tried these, they didn't really work all that well. A couple of other, but we're gonna try and see if they'll work on a new machine since there's been some updates posted. But this would be really awesome if we could get it working. And then what else is there to talk about? Let's see. Does anyone have any questions so far? Doesn't look like it. But so we're just gonna be going over this. I'm gonna be doing some dev, like reviewing how the cough loader works, as well as just kind of the PE file format, because the concept's really cool, but it is a little tedious because we basically have to build image files in memory ourselves. That's kind of Trusted Sec built a short overview of how cough loaders work, but it's very, very like top level. Which basically you basically just have to build your structures and then put all the stuff in. So the concept's really easy. It's just relocating a structure in memory and then providing a function pointer that gets executed and executing normally. And because it has it has its own IAT table, the program will just execute. Unlike shellcode where it's just running that code that you give it in line and executing as it goes. Since a cough image has a full IAT table, you can use it much more like a regular executable where you just point it to a single function and then it can do like it can have multiple execution paths because all the offsets and everything are there for the program to use. So it's just a lot more effective and flexible than just straight shellcode, which is what makes it like advantageous. And I realize you guys, there's like no way you guys can read that. Let me. Is that better for people that are on now? So these are kind of like the main sections that we have to have. And the two kind of primary projects that exist right now for using cough/BOFs outside of, so BOFs are a type of cough, which stands for a common object file format. It was actually like originally like a Unix file format, but Windows also supports it now. It's just cough relocations. They still refer to it as a PE file, which is what their executable files are, is the PE format, but they do support like cough relocation now. So there's the Trusted Sec cough loader, and then there's runoff, and I'm gonna start by just reviewing the code. I know how they work in principle, but I've never written a cough loader myself, so some of this is just going to be digging through the code and seeing how these things work. Runoff's been around for a while, same with Trusted Loader. You can see that theirs is a little more actively supported, and then Runoff has some other stuff that's pretty cool. but hasn't been updated in a while. So runoff is what Empire currently uses. So Empire already has a way of running BOFs in memory. Sorry, I got distracted talking about these, but BOFs are COFs. Really, all that makes a beacon object file. A beacon object file is the template that they've pre-built that allows you to interact with some of the Cobalt Strike APIs. And we don't really need those since we're using like Empire or some other code. Like when we write the IronPython loader, it will be independent of Empire, but you can use it in other C2. So we're going to be doing COFs in general rather than BOFs, but you'll still see like a lot of people to still refer to it as like a BOF runner because most people don't want to rewrite tools that all of the BOF files. So like there's a ton of like TrustedSec has like a whole BOF repository that we can go pull up. Yeah. So they have like all of these situational awareness BOFs, which is what a lot of people use for demonstration of BOF loaders. Is usually like one of TrustedSec's like situational awareness one. Like a lot of times you'll see demos with people just using the really basic. Where is it? Where am I? Down here. Yeah, so like one of the things that these are used for within in terms of OPSEC stuff is that if you run like who am I /all in PowerShell or cmd.exe, that sets off a ton of alerts for AV/EDR because that's like the first step in enumeration by a lot of people, and so they flag on all that. So a lot of the things that have been built for BOFs, because the other major limitation for BOFs is that they are single file C projects. They can't be very large, complex files with like lots of classes and stuff. So we're not building like an entire tool in a BOF. We're building like discrete functionality. So a lot of enumeration stuff has been rebuilt in BOFs to avoid AV and EDR detection, seeing like PowerShell.exe running who am I. So I know a lot of people say like that's opposite. So that's one of the main functionalities, but this is one of the ones that people primarily use for showing like their proof of concepts. So, oh, cool. Someone said they have canary tokens I assume to look for the BOFs being loaded because there's still like detectable strings. One of the other things that you're doing with a COF object is basically our C2 / the parser that we build is acting as like the linker, which is what normally the compiler does for you to turn it into a full exe. But we're acting as the linker and like building the symbols and all that kind of stuff. So we're kind of acting like a little bit as a compiler. Yeah, that one. Yeah, that's definitely like one of the things that has been built recently. So sorry, I was checking a message that I got. So like I said, we're gonna go see. I need to pull up my VM. So I want to see if we can get one of these. One of these power. So if we get one of these Python BOF loaders to work, the conversion to IronPython will be much easier. IronPython has like interfaces for all of the .NET stuff. So if we can't get a Python one that already works, we could try converting this runoff one because this runoff is all written in C#. So I guess we can start with like walking through runoff a little bit just so people get an idea of how they work. So like if you go into program CS, like there's not actually, let's just download this and open it in Visual Studio. That'll be much nicer for us to look at. Let's see if it gets flagged. When did I get McAfee in this? Whatever. So while that's loading, I guess I'll pour myself some whiskey since we're doing code and Cask. I'm gonna start with like, this is actually not like a bourbon. This is like a corn whiskey, which is like interesting. It's from this company called Master Pick, which has some like really old Jim Beam and stuff that they've published. But like the bottle that I bought doesn't match any of their published stats, so I don't have any idea what's actually in this bottle. But it's pretty tasty. But I don't care about all this. What's new? So we'll just go ahead and start with C program. But normally there's not really anything interesting in this. It's mostly just startup stuff. Where the interesting stuff is they parse their arguments, which we'll talk about later for how BOFs work. Because one of the hardest things when you're building a BOF runner is figuring out how to parse the arguments, because there's a lot of iterations in the way that arguments can be passed into a BOF. So that's one of the biggest challenges of integrating a bot like runoff, or there's like invoke BOF that's been written in PowerShell that we got rid of in Empire, because we originally had that because it didn't parse arguments very well, and so it was really limited on the BOFs it could run. So the parsing the arguments is something we can come back to later, but BOF runner is like where our kind of bread and butter is. So you did my computer. Good. There we go. Go to implementation. Cannot. Okay, I guess we'll just do it manually then. So this is like where it gets like, you can see, it's not the most complicated thing, because like a lot of the other functions are in other stuff. But so they bring in the functions. So they have a helper object file. So we're gonna want to go find. So this is like where our cough is. We're gonna need our native declaration, and then we're gonna need this IAT. So like I said, we're gonna have to build the IAT ourselves in our files. So native declarations is just a helper file that basically does all of the p invoke for anything we're going to need. So like one way that is interesting for this is like, since it's run off and using p invoke, that's a way to detect this. We could potentially upgrade this project by introducing like dynamic invoke or rewriting it to use like direct syscalls, but that'd be a lot of work. But so this is just all of the p invoke and structures that we're going to need within the file. I don't know why that structure is indented like that, but whatever. So let's go back to let's just walk through this. So we start it, they implement our BOF runner passing in our arguments. So we're going to go back to our BOF runner. And so the first thing we do is define beacon functions, which haven't been done yet. They're getting the resource names from the assembly that we're running. So that's just finding the p invokes that we're previously defining. Contains runoff.beacon functions. Has anyone walked through this before? Oh, they have okay, that's what they're doing. They have an embedded cough, basically, or well, it's not really a cough, but they have an embedded beacon object, or they have an embedded C object right here that they're using. That's what they're looking for in the manifest. Okay, so those are already predefined. Oh, okay, I get it. That's in case they wrote C code that executes the functions that were beacon APIs, and so that it's standalone without needing the beacon actual payload in memory. That's what it is, which makes sense. Oh, let me zoom in again. I'm sorry, I keep forgetting that. Someone ping me if I forget to zoom in on any of these files. Let's see. Let me check. checking on something real quick. Cool. Okay. So we're all good here. I'm just making sure we're still working out the kinks of our streaming platform because we just got a new one. So, okay. So we call our beacon functions so it knows how to do them. We create a memory stream here. Oh, then they're just okay. Yeah, so they're just copying the code into here to relocate it. Where is beacon helper defined? So it's in cough. So let's go look at our cough file. Okay, so this is our structure. We set our architecture. Yeah, so it looks like this is just building our structure in memory. This is always fun. Yeah, so this is just our import prefix. Okay, so I think this is supposed to say this doesn't have the string table doesn't have an offset, because I believe that's true if we go read the Microsoft documentation. Or actually, trusted sec set it in there, in here. Maybe not. Never mind. Maybe it does have an offset. I thought I read that it didn't have an offset previously. So this out. So yes, this is just build stuff that we'll have to re-implement. So the nice thing is that a lot of this, when we go to build this in IronPython, we can almost cut and paste because the types they're using are they're not using C types. Although, so one of the big things for IronPython development when we get there is we got to decide if we want to do stuff in C types or if we want to do it in .NET types. If we're out of memory manipulation using C types is usually a little easier. So we might convert all this to C types when we get there. But okay, so we kind of got that. So this is just building our PE image and parsing it. We'll come back to this. So we haven't gotten there yet. So we created our cough. We haven't defined the IAT yet. Okay, so now we need to define our IAT. Which is just a bunch of int pointers. Okay, so we'll come back to this. Yeah, so our helper object file, which is the one that they already built here. And then we load the BOF. Yeah, so pretty straightforward. Like I said, the overarching concept of BOFs is not that crazy. It's just memory management of structures in is like not the most intuitive because we just got to do lots of pointer math. So this it's not that much code. It's actually less code than I expected. Although we got like I said, they got to figure out how to parse the arguments, which is actually like the longest thing in here. Yeah, image parts. So we'll come back to this. Let's see if we can get this Python project to run. Let's open PowerShell and make sure I still have Python. And so another interesting, I don't have Python installed on this computer. Okay, let's install it real quick. I don't know if anyone saw my tweet earlier today, but we've been trying to build a process injector, like a shellcode injector in Python, and we cannot find one that works. Like we've rewritten one multiple times, and it always crashes. So the shellcode executes, but the parent process always crashes. And we've tried like a half dozen open source projects, and they all still crash. They all still crash the parent process. So we haven't found a single Python shellcode injector that actually works without crashing the parent process. We found someone that referenced maybe like the shellcode needs to be different to not crash the interpreter for Python. But like if anyone has any ideas on how to execute or knows of a working Python injector, please share because that would be very helpful for us right now. So we're just waiting for this to install. Is anyone planning on going to Black Hat or DEF CON? We'll be teaching there, so we're looking forward to that. Setup was successful. Okay, so we should have Python installed now. Yeah, I'm really excited to teach some of the OpView evasion class updates that we've built. There's a lot of IronPython. What the hell? Sure. Okay. Well, let's go look at runoff while we're waiting for that. Or let's go look at this like PyCoff and see. So this doesn't look like it actually executed. It looks like it just prints out information on it. But the one that comes up the most often is this PyBof. So this was built last year. I'm going to go ahead and download the code. And we need to download a pre-built COF. Forget, does the trusted sec have one? Already have them have like compiled ones? No, yeah, these are all precompiled. Okay, cool. So we're going to want this one, and we're just going to download the file. Cool. That's a bummer that you're not going to be able to come. It's, yeah, I mean, I really enjoy DEF CON and Black Hat, but they're definitely not what they used to be, unfortunately. So it says it downloaded. If I type in Python, is it installed now? Okay, cool. We got Python. Okay. So where's this PyBOF thing? PyBOF. Okay. So I'm going to have to import PyBOF. Looks like. Yeah, import BOF. Okay. So I need to go find where that BOF file is and move it into. Let's see if I can be lazy. Just import that whole folder. Although I am interested to see at DEF CON how that's IronPython. Where's Python installed at? Okay, why am I failing at finding this? So IronPython, LM. Python's not showing up here. See, I might be able to just give it the file path. Let's do that. C : user. Oh, I forgot I can't tab complete. Actually, I'm totally blanking on what the proper way. I think it's just the directory. Oh, I have to add it. Okay, there we go. Knew I was doing this wrong. Downloads, PyBOF. Think this will be good enough. Oh, I'm using a different username anyway. Oh, duh. always have to check your backslashes. There we go. Okay, so why is this not working? Yeah. No, I don't. Okay, I'm failing at my Python. Why is this not importing? Oh, I need to build it first, it looks like. Oh, I have to compile it first. That's why. Read the instructions. And then, right, setup. Yep, okay. So, okay, this is not working as expected. Why doesn't the build function work? No module named setup tools. Okay, what am I doing wrong? Is Python setup tools a thing? Maybe I just need to do a pip install. Okay. There we go. Okay, so now we just gotta go. Where did that output to? So that build, copy the resulting PYD file. So it's gonna make sure that's. Oh, we can just do an ls. Oh, there we go. Okay. That's a funky name for the file. Sys.path. Okay, maybe I need to import that stupid name. These instructions are not great. Change directory to parent of BOF directory. So copy the resulting PYD into the BOF directory. Okay. Someone please like let me know if I'm doing something stupid here. Or if you've used this project before and it's just dead. So let's go look at this. So we're here and it wants us to copy it into BOF. Then cmd to the parent of the BOF directory, which is this. We'll run it from cmd just because that's what it tells us to do. Oh, it didn't tell us it couldn't find it, so I guess that's slightly better. Fatal Python error, PyImport append. Does anyone know what this means? I'm definitely not the Python expert. Anthony is more of our Python expert. PyImport append init tab may not be called after PyInitialize. No, it was the same runtime. Okay, maybe this just doesn't work. I don't know why it would make it different to run it from here, but let's try. Nope, same error. Okay, we'll move on to trying and doing this, recreating the runoff in our IronPython, which is going to be a pain. Or well, hold on, there's one other project we can try. Anthony just dropped me one. Let's see, I got, okay. I apologize because I'm trying to find this project that Anthony linked to me. There we go. So we have PyCoff. Let's see if this works any. And this was written a lot longer ago, which might not be bad. Oh no, this is the one that, sorry, this is the one that parses. It doesn't actually run it. So Python BOF loader. There's Python BOF loader. Oh, this one requires shellcode, which defeats the whole purpose. So we can try this one. So let's see. So we have to build the COF loader. I don't have MinGW installed on this. Okay, we're just gonna try and rebuild it in our in C# then, which is going to be a project. But if you guys haven't seen, we do have a ticket dumper in IronPython working now, which is really nice. So now we're starting to push out a number of things. Like Anthony has a PE runner that works in IronPython that we're going to be pushing out next week, I believe. That's pretty cool. I think if he's going to make a demo video of it, but like if you use it, because IronPython creates so many problems for monitoring solutions, if you have like Defender turned on and try to run Mimikatz, it obviously doesn't work. But if you run Mimikatz through our PE loader, it creates enough confusion because of the way the Lambda compilation like mangles the code that you don't have to do anything and Mimikatz will just run. It's pretty cool. So that'll be coming out next week, which will be nice. So yeah, this was me playing around with some development stuff of proving how to build delegates and do direct syscall type of stuff in IronPython. So we now have this working. Yeah, we finally actually went and asked the IronPython devs on how do you build delegates, and they shared this like really obscure library with me, and you can now build delegates. So it turns out you can build delegates in IronPython like directly, and so now you can because the way that a lot of people were doing things were building generic delegates, which you can't use with a marshaller. So now we can build delegates this way, and it fixes a lot of problems. So lots of cool IronPython stuff coming out. Yeah. So let's just create a new file. And we're gonna start working through this code. So if anyone if anyone has any off-topic questions, feel free to ask. Like there's nothing This is what I had planned to go over, but if there is a communal want to talk about something else from you guys, we are, I am more than happy to switch it to something else. So just let me know. But we're going to start working on building out this IronPython from the runoff. Anthony wants me to try and build it off of the cough loader from C, but I don't know. That's like a lot of work. Actually, I guess it's not that much. And if we're using C types, this actually might be easier. Anthony thinks that the trusted set cough loader handles arguments a little better. So maybe we'll try this. So we don't need any of this. Oh, beacon compatibility.h. So if we're gonna do it this way, we might have to go build this, which is kind of, see how big this is. So these are relocation types. So this is just a struct, right? God, my C is so bad. Why aren't, are these structs or are these individual objects? Oh no, they're not structs. Okay, so these are just individual objects. So if we use C types to find these types, then it should be fine. This is going to be kind of boring though. Wait, what's the uint 16T? I don't know what the underscore T is. Okay, no, we're just going to go off the net runoff because this will make way more sense for converting without needing to rebuild it all. But we're going to have to figure out how to run this. Or, well, no, they just build an object and then use the runner to run it to construct it in real time. So we can do that later. So we have this. So these are enums, so this is easy. So I'm actually gonna, not like a good way for me. Actually, maybe let's see if I can figure this out. Hold on. Oh no, I can only share one screen. That's unfortunate. I wish I could share 2 screens at a time. So because we're gonna need all these. So we're just gonna go ahead and grab this. Good news is, and then we're gonna save this as where's Python? There we go. So we get our nice syntax highlighting. And now comes the boring part of writing out. So I will say, like, developing in IronPython, one of the hardest or one of the longest parts is just getting your class definitions appropriate, and it's really like not the most fun thing actually. So we're not going to have a class runoff. We're just going to have our various enum types. Let me open up my ticket dumper. It's not here. Let me grab the ticket dumper because I might just be able to cut and paste some of those structs. So we're going to want to use our C types to make this easier. So we've been debating back and forth. If you guys have any input, it would be interesting on whether or not, so there's kind of two ways we could do our development for IronPython. We can use C types because we're bringing the whole standard library anyway, or we can do something like, not this one. Hold on. Like this. So this allows us to not require the entire standard library because we're basically doing pinvoke on the .NET classes, which means we could kind of shrink the size of the payload some, and is kind of, I think, like C types, going through C types might be less monitored if people start monitoring for IronPython than doing like a straight pinvoke. So we've been debating whether or not it's certainly nicer from a code reading standpoint to use C types because you don't have to create all of these funky pinvokes for each one. But I'm not sure which one from like a like an OPSEC standpoint would be better. Because one of those things, like at the moment, it's kind of irrelevant because there's not really anyone that's monitoring IronPython. So it's really easy, but in the future, I don't know which one's going to be stealthier, so we'll have to do that at some point. So, so we've got that. Yeah, because the nice thing about C types that I don't really know a better way around right now is that C types defines a structure for us so that we can cut and paste a lot of our classes in here. So this is going to be our image file header. And the other weird thing is that when we do this, you can't just like define it normally. You have to create this fields is how IronPython creates it. Which is unfortunate because it makes cut and pasting a lot. You can't just straight up cut and paste. But I am going to cut and paste it over underneath so we can see what we're doing. Nope, I lost my mouse. There it is. So anyone got any cool things going on? I'm going to Chicago tomorrow. That's actually why, not like, why we were doing it on a Thursday. Although I am curious, we've been debating whether or not to just move our stream to Thursdays. Do you guys think that that would be better, or do you think we should go ahead and just stay on Fridays? Sorry, I'm trying to read my type notes because the other thing is like some of the C types are kind of weird. Oh, whoops, that's not a C types. This is machine, which we'll have to go figure out where that definition is in a second to implement it. But if this is like honestly like one of the more pain parts of doing like code development is just having to cut and paste or rebuild all our structs. Oh, whoops. Because there's going to be a lot of them in this. Let's see. We haven't got any questions yet, but so yeah. So the next code in Cask, because we're gonna because this is the off week because of July 4th this year, but next week we'll be going next week because are on time, and that will be on Friday unless we hear like a lot of feedback from people that they would rather it be on a Thursday. Oh crap! Some of these are not all Uint 16s, and that would come back to bite us when we're trying to troubleshoot why everything's crashing in memory. Pointer symbol table and the number of symbols. Oh no, symbols. Size of optional header. Oh. I was really hoping that run PE one would work, but no luck. Yeah, so part of the reason that we're building this is there was a thread a little while back about what do people think are the most needed features in a C2 for them to use it. And BOFs, the ability to run BOFs is like one of the #1 named ones. So we really want to get this, even though we already have a C# one in Empire. So IronPython, the IronPython agent can use C# assemblies, but we're trying to get to the point where you can run like your core functionality in an op all in IronPython to avoid some of the C# indicators and make it harder for the AV EDR detections. So we're gonna have, this is gonna be the next tool. We have the like run PE that's gonna be coming out. We already have like that ticket dumper, and I'm gonna extend it some more to add some more like Rubia style functions for your Active Directory exploitation in IronPython. I know process injection is considered bad OPSEC, but we're all about threat emulation. And if you go look at like some of the Red Canary stuff, the #1 divergence in what Red Canary sees from actual threat actors and what they see in red teams is the lack of process injection by like red teams and pen testers, even even though like a lot of APTs are doing it now. That gets into the whole confirmation or like reporting bias of red canaries only reporting on stuff they caught. So, and a lot of people would argue that the reason you see so much process injection in the APT reports from red canary is because those are the ones that they're getting caught because they're using bad OPSEC. So kind of a chicken or an egg, but we still think that like you should have the capability to do process injection, even if you shouldn't be doing it. We think you should like that it needs to be had. And then the final thing, once we get the BOF the runner working, is to build a SOX proxy fully in IronPython, and then we'll have kind of most of the core functionality you need for an op. So that's where we're going with Empire. If we get there, we'll see how long it takes me to build this BOF thing. What am I doing? I'm making this hard on myself. And at least on enums, we can just like pretty much straight up cut and paste. It's kind of nice. Let me double check that that's how you'd make an enum. Yep. Okay. But before we let's go figure out where this machine definition is. Oh, I'm an idiot. I wrote this totally backwards. Trying to find that was very silly of me. One thing to keep in mind when you're doing IronPython stuff in your class is before you use it, so that enum needs to go above and so that was silly of me to do that. I've never seen a type on an enum like that. I'm not gonna worry about it. I'll come back to it. IronPython should just handle it. So now for our next one. So did anyone sign up for our workshop at DEF CON? I know Sin Potter can't go, but I'm excited to be teaching our Empire stuff. Small chance that we'll have this that I'll have this done in a month when we get out there. It'd be fun if I could have it out there, and we may incorporate some more additional stuff to the IronPython workshop, or not IronPython, the Empire workshop. I apologize. Hey guys, I apologize. Not surprised that a lot of people left. We are having flooding from the Mississippi River in St. Louis, and I think it might be impacting my internet because I've lost internet like 3 times today. So I apologize for that. Ugh. Oh, it looks like we do have most of our people back. So I'll say that again. Sorry, everyone. We are having flooding in the St. Louis area. We got like the remnants of Hurricane Beryl came through yesterday or the day before, and so like we have like a flood. We are having ongoing flooding until Saturday. So that my internet, hopefully the internet doesn't cut out again during the broadcast, but if it does, just know it's because of our ongoing flooding here. At least I haven't lost power. I lost 2 years ago. I lost power for a week after we had like one of these big storms come through. So I was asking, does anyone know how this like marshal as within a structure works? I don't know that I've seen that before, so I'm gonna look up how this image symbol works. But that was very unfortunate. The internet cut out, so I apologize, guys. Should just see if anyone's done it. So he'll have had to have built this enum. Yeah, so he's using C types. Was it image symbol? Huh. Okay, so what were the image symbol type, section number, storage class? Here, let's search for storage class. Oh, he's using a pointer. Yeah, they're doing this in a weird way. I don't know why they're doing that marshalling, because this doesn't have it marshaled. Okay, so we're just going to ignore that marshal. We'll see if we may have to come back to that to figure out why it's not working. We're just going to ignore it for now. Trying to remember how to do byte array. Actually, I think where's my tick dumper? I have too many windows open. I'm sure you guys can relate. Okay, we'll just open it over here. No. Can't remember if we can do this. Try this, but I can't remember if I'm allowed to do that or not. So but like I said, this is the most tedious part of doing this. Did anyone else get any wild weather this week? Hopefully no one's in Houston, although I guess you wouldn't be on the stream if you were in Houston because they have no power. But yeah. So yeah, once we get all of these in, we still are like only part of the way there because we've got these are just building these out. We actually haven't built any code to test any of these structures with, but type management in IronPython is a pain in the butt. But we'll get there. Let's see. But let's see what else is going on. Pointer to relocations. Pointer to line numbers. Oh, you guys missed it while I was worrying about the fact of whether or not my internet was going to come back. I did pour myself some more whiskey. So now we're drinking 1792 Full Proof. That's a Sherlock's pick from Atlanta. They're like one of my favorite places, although Sherlock's no longer exists because they got bought by another company. Georgia has some weird liquor laws in the sense that you can only they don't allow for large conglomerates in Georgia. Well, like you can be a large conglomerate outside of Georgia, but like they have a law that only allows you to own 2 locations for liquor stores. So like Total Wine is only allowed to have 2 locations in the entire state of Georgia, whereas like here in St. Louis, Total Wine has like 4 locations in St. Louis alone. not counting like any locations in like Kansas City or anything like that. Or not 4, I guess there's only 3 here technically, but point being, they have like Georgia has like these weird rules where you're only allowed to have number of relocations. We're only allowed to have two stores, so it's like interesting. So like Sherlock's, I think still exists. I can't remember if the guy retired, or if they just wanted to like create a bigger store, but because they already had 2 stores, they had to sell off the one they currently owned. And then characteristics, and then we're done with this one. And then if anyone's in the St. Louis area, the St. Louis Bourbon Festival just started selling all their tickets, and I highly recommend going. It's a super cool time. I will be there next year, or this year. I go every year, actually. Okay, so that's everything in this struct. I wonder if ChatGPT could reformat all of these for me. Should we try that? Just give it the file and say, like, put these into IronPython structures. I don't think it would do a very good job, to be honest. Wait. Oh no, did I just rebuild the same one twice? Oh no, okay, they just look similar. Oh, they have more of this unmanaged type. One, two, three, 4, 5, 6, 7. It has more than 8 fields. I don't know what this is doing. Because they have it again here. Because this is a structure, and yeah, I don't know what they're doing here. So we have some enums that we're going to have to go build above this again. That's okay. Image, symbol. Oh, why would you? That was weird. Oh, do these both have that public byte name thing in them? Is that what threw me off? Oh, they do. That's what threw me off. Okay. Yeah, I've learned way more about Windows internals than I ever expected when I first started this. Started doing like hacking stuff. I always thought like I'd never get this deep into it because I started off as a captain in the Air Force, or actually as a second or first lieutenant when I started doing cyber stuff in the Air Force. And I always thought I would just be like kind of a manager and not the person doing hands-on keyboard, which I like the hands-on keyboard stuff, but I never thought I'd be this deep into Windows internals, and it is an adventure for sure. What else? I don't know. I feel like you guys just listen to me droning on. It's still weird. Like we've been doing this for like 2 months now, and like just kind of pseudo talking to myself is like still weird. Sorry, I keep saying because I'm trying to think of what to say next. Does anyone have any questions on like OPSEC or anything like that on various things, or any questions on emerging trends? So something that's interesting in terms of emerging trends is I've been seeing an increasing amount of APTs that are going back to VBA again, which is very it's surprising and not surprising at the same time, because VBA or because the number of companies that I've seen that's like just straight up disable all the Microsoft stuff. Like I used to work at Boeing, and when I was there, like I literally got a spreadsheet from the finance office. The first page of it was to how to turn off all the macro protections in Microsoft and like override stuff. And so lots of finance uh, offices and companies do that. So it's not surprising that the VBA still works, but you would have thought that it's gotten hard enough for people to abandon it and start doing something else. I mean, I hate myself, so I kind of like programming in or like VBA tradecraft. It's just because there's some cool stuff you can do with it, but it just seems like there's better stuff out there now. Like the what's his name? It's not Flank. They go by adepts of whatever. Let's see. This guy, these people, have posted some really cool. Oh, Excel, that's who it was. If you haven't seen this offensive VBA, sorry, I'm ADDing you guys. If you haven't seen this offensive VBA thing, it's really cool. This is probably the coolest trick of that I saw that I never thought of doing. That is probably applicable to other places, but you can get, if you declare a function with a really long name, it basically creates a like writable area of code that you can use for memory that's like automatically allocated for you. It's kind of cool. It's a really cool concept. But sorry, that was like a total ADD moment. But it's really interesting. He's done a ton of really cool VBA research that I would like highly recommend reading. Because like I said, threat actors are starting to do it again for whatever reason. I don't know that we'll ever go back to doing that as like a primary method of like initial exploitation, but it is interesting and fun. Maybe if we continue seeing a resurgence of it, maybe I will get to play with it again. At least for the enums, we can essentially just cut and paste. Does make our lives a lot easier. Can't remember for enums. Do you do the comma? Hold on, let me pull up my IronPython stuff. I might need to delete those commas. Where's my IronPython stuff? Where did I close the? I might have closed it by accident. Nope, we don't need the commas. Okay. So we do need to delete these. Okay, so we built those two enums now, so now we move on to our next structure. Got something in my eye. So for those just joining us, we're working on building a, because I've seen that our numbers have fluctuated a little bit. Didn't mean to have that up. We're working on building a COF or a BOF loader in IronPython, which we're doing the very tedious part of having to build all the structures right now, which is like kind of, like I said, tedious, but we have to do it. So the way you do it in IronPython is creating these C-types structures, and you have to create a fields dictionary that contains all of your values within the structure. And then you go from there. So we don't actually get to test any code until we build all these, and then we have to build the rest of the code. It's definitely not the favorite part of doing tool development, but if you ever want to learn how to do tool development, then you're gonna spend a lot of time, especially if you start doing anything within Windows internals. You're gonna spend a lot of time working on structures, but just the unfortunate part of development. So we're gonna have to go build another enum in a second. Ooh. I don't know how to do this in IronPython. We're going to have to figure out how to do this in a second. Oh, but we get to we're at the end of our first part of our enums building once we get this built. Okay, so we're going to go. ChatGPT is actually very good at Windows internal stuff for whatever reason. So we're going to see if we get an easy kill out of this and just go ask ChatGPT how to do this in IronPython. Or we'll ask it in Python. That'll give us a close enough answer. Or we'll ask in IronPython and see what it tells us. Very high probability that it lies to us, but yeah, so it's just ignoring that switch. Okay, so it wants us to build two different structures. Oh, okay, I see what it's doing. That probably works. Yeah, we can probably just steal this code and go this way. Yeah, let's try that. Probably the best we're gonna do in terms of for now. It's at least a reasonable answer that it gave us. A lot of times it just makes stuff up, except like I said, for some reason it's very good at Windows internals. Even though like a lot of Windows internal stuff is relatively like obscure. So like it would be something that you'd think it wouldn't be good at, but because it tends to hallucinate stuff. Just for a sanity check, let's just Google Python architecture switch to see if we get anything different. No, I'm not seeing a better answer, so we'll run with this one for now and see if it works. Okay, so that builds out our initial images, our initial C types. We may want to. So we made this iron runoff. I don't know that we want to put this all in one file. I guess we'll keep working out of one file for now, because bundling multiple files together is kind of a pain. Why did we do that part first? I don't know why we did that first. Because we have to parse the arguments. We can build this. This is probably fine. This should be relatively easy to build. So let's see, class, parsed args. At least we haven't lost internet again, so that's always a good sign. And then camera is at 1 or 2 underscores. I think I did it in here. Oh, no, I did do it in my iron offense stuff, though. I'm so bad at remembering how to do things. No, definite. That's what it is. Oh, that's as much as I can zoom in, apparently. Oh. Sorry. Okay. So, what am I looking for? Okay. Let's look at our code again, because that's... Oh, that's right. I need to do the self. Okay. Oh, wait. We don't need to... Duh. We don't actually need to init these. Or, well, we can for the ones that actually have values, but the ones that don't have values, there's really no reason to init them. Okay. So, actually, we'll just do this. No, not self this, or this, self. I always forget Python array is weird. Yeah, we're just going to skip the file bytes for the init call. We'll build them later once we actually read them in. But we can do the thread timeout since it actually has a value. So for those that joined late, what we're doing is we're rebuilding runoff from Netitudes in IronPython. So it's here. I'll send it out to everyone. So there's a project for everyone. If you're watching on Twitter, I don't think I can post comments with this for some reason. But so we're rebuilding this in IronPython so that we have a runoff, because if you go look at some of the interviews and like Twitter threads from people on what are the key enablers of tradecraft nowadays for like a C2, BOFs are considered like one of the must-haves now. And so we, even though Empire already has a way to run BOFs through runoff, which is a C# assembly that you can run for BOFs. We want to try and get Empire to be able to. Our goal right now is for the Empire project is to get to being able to operate purely in IronPython and not rely on any of the C# or other things. Because, for example, Anthony's going to be releasing a run PE IronPython tool next week, I believe, or maybe the week after. And like if you can run just like pure Mimikatz with run PE and IronPython, and because of the way the work using Lambda expressions for DOR, like Mimikatz will run by itself without any additional changes just by running it through IronPython. So if we get everything through IronPython, it messes up a lot of detections for stuff because of the interactions with the Lambda compilers. So we want to get everything to running just in IronPython for Empire. Is our plan going forward is for most of our development to be in IronPython. But we're getting down to the last 10 minutes of the stream. So I don't know if anyone has any questions or anything they want. Feel free to ping us. We are going to be doing. We are going to be teaching at Black Hat. So if you want to join us for some classes there, I will be teaching some IronPython tradecraft in the evasion course, as well as like our script block smuggling stuff that we taught, and some other cool stuff. We walk through. If you've never done obfuscation, like intentionally, not just kind of running like automated tools, I will be teaching like theory behind obfuscation. So there's a lot of interesting stuff you can do with obfuscation, and there's actually a ton of research into obfuscation from a IP protection standpoint. So like software companies have done tons of research into code obfuscation to prevent reverse engineering, like by competitors. And so if we go look at some of the academic concepts there, we can go build like entire methodologies for obfuscation that are very powerful for taking like open source tools and making them very hard to detect because of the way we're implementing obfuscation. So it's one of my favorite classes to teach, and we'll be teaching it. I'll drop a link for you guys here in a second for the class if anyone's interested. We will also be teaching an Active Directory course, which will be taught by Kevin, who I believe contributed to the COF Loader some. But let me grab that link for you guys. I'll grab both the links. But we'd love for people to come join us at Black Hat. And if you can't join us there, we'll be at DEF CON. Unfortunately, we will be teaching a workshop at DEF CON, but unfortunately, the signups opened yesterday and they sold out in about 2 minutes from my understanding. So if you're not already signed up, it'll be difficult, but you might be able to find tickets from someone. DEF CON has like a thread on their forums that allows people to ask around for stuff. So I don't know that we really want to rebuild this whole debugger that they have in here right now. Like, we should do it eventually, but I'm going to talk to Anthony because he's built some of these args parsers. There might be a like instead of rebuilding this argument parser, I think there's a Python arg parser that we can just reuse that will save us work. Hold on, let me Google it. Yeah, Anthony's done a bunch of this, so maybe we should not waste on rebuilding this parser by hand because I think we can just build an argument parser with the argument parser in Python. So I'm gonna skip that for now. Yeah, there's no reason to build all this. This is just all over. Okay. So we probably need to go, or actually we don't need to build any of our native declarations. Well, maybe these values, but this is all for p-invoke stuff. And since we're using C-types automatically handles p-invoke for us. So I don't think we need to rebuild any of this. Well, we might need some of these structs, actually. Actually, we probably need a lot of these structs and enums. We'll probably need to add these in there. So that'll be what we do next. And then I think the next thing to tackle is going to be this IAT constructor. Because we're going to have to figure out how this works. Yeah, see, like this is going to be a pain in the ass to figure out. It's going to hurt my brain when we get to this. But I said we got that, and like that's gonna be it for the most part for this week. We got a couple more minutes, so does anyone have any questions or anything? Let's go see. I'll go check Twitter real quick to see if we got any questions on the post or anything, because it's not sharing those through our streaming platform. Nope, doesn't look like we have anyone on here. Okay. Yeah, so to kind of review, like, we rebuilt like a bunch of enums, which unfortunately is like just super tedious, and it took me like an hour just to rebuild all these, which is definitely like not the most interesting thing, but we got like a lot of the hard part out of the way, or well, tedious part. The hard part comes when we start trying to execute this code and it's not quite working for no reason. So yeah, so tomorrow or next week, we'll probably be working on this more. I'll probably make some progress on this in the next over the weekend. But so we already rebuilt the image parts file. We don't need to do native declarations because C-types handles all this for us. IAT we're going to need to rebuild, but we might want to do that a little later. So the next part is probably this cough file that we're going to have to rebuild. I might be able to get this done before we get back together for our stream next week. But it's, yeah, we'll see. It'll be interesting. Or I might put some more time into trying to get that Python one to execute, because it looks like it worked at one point. But we never went and checked the issues. Let's see what it says in issues. If there are no issues. Yeah, so maybe I'll be able to, I can and to run, but it hasn't really been worked on in a year, so it would be really nice if we could get, if we get this working, but who knows? It looks like the project was relatively abandoned. Let's see, this, I didn't check this. This is always something to go check. Let's go look at the insights and see if there's someone else that's forked it and been working on it. Oh, reverse shell forked it. Just do anything with it? No, it doesn't look like it. So let's go look at network. Oh, did he do some work? Oh no, this guy forked it off of reverse shell. Oh. Maybe I need to go to reverse shells and try building his. Oh no, so I'm confused. That doesn't make sense. Oh, because I'm on reverse shells. Hold on. I'm stupid. Okay. Now let's go look at network. There's only 8 forks. Why is it taking so long? Yeah, no one's pushed to it. Okay. Oh well. It was worth a try. But thanks everyone for joining. I appreciate it. Have a great weekend. I'll see you next week when we're back on our normal rhythm. But thanks for coming out and watching me do some tedious structure builds, but it is interesting if you never built a tool before. So I hope everyone enjoyed. Have a good one. And sorry for the internet cutting out halfway through. Like I said, we're having some floods.